Hi, we're Eunji Kim studying for PhD and Jiseok Kim studying for master's degree, and we are part of Team YaHo. Today, we are going to talk about our research proposal on membership inference attack in dataset distillation-based federated running. We'll be covering the following: an introduction to federated running and dataset distillation, look at some related studies, our research plan, and our expected outcomes. First, let's start with federated running. Basically, federated running is a way to train machine learning models without sharing the actual data. Instead, each device sends just models weight updates. The way it works is each device trains the model on its own data and then sends the updates like weight changes to a central server. The server uses a method called Federated, which averages all those updates and improves the global model without needing to access any raw data. This way, the data stay private, but model keep getting better. However, these are some challenges with federated running. First, communication cost can get pretty high because sending updates between client and the server use a lot of resources. Second, there are the issue of non-independent and identical distributed data, meaning which client has different type of data. This makes it harder for the model to work well for everyone. Lastly, there are security risks like membership inference attack, where someone could figure out if specific data was used during training, which is a big privacy concern. To deal with this issue, using dataset distillation in federated running has started getting attention. So, what exactly is dataset distillation? Dataset distillation is a technique that compresses large dataset into much smaller, more representative dataset, but still manages to maintain the performance of the model. This means you can train a model on a condensed version of data without losing much accuracy. It's especially useful because it reduces the amount of data that needed to be stored and communicated. This significantly cut down on the storage and communication costs, which is big deal in federated running where devices are constantly sharing updates with the server. Another key benefit is that dataset distillation works really well in environments where resources are limited, like edge device or mobile phones. Since this device has less storage and computational power, minimizing data transfer and processing is crucial. With dataset distillation, this device can still contribute to improving the global model without having to deal with massive data. So why use dataset distillation in federated running? Using dataset distillation with federated running has several benefits. First, it cuts down on communication costs because only smaller, important datasets are shared between client and the server. This reduces the amount of data that needs to be transferred. Second, It helps deal with non-IID data by creating balanced synthetic dataset. This makes the model better at generalizing across different clients. Lastly, it makes the system more efficient, especially for edge devices with limited resources, by reducing the amount of computing power and data transmission needed. However, even with this benefit, there are still security risks like data poisoning, membership inference attack, and so on. And out of all this, we are mainly focusing on membership inference attack. Now, what exactly is a membership inference attack? It's when attacker is able to figure out if certain data was part of training process. This is especially concerning when sensitive data like medical or financial information is involved. But even with federated running and dataset distillation, this kind of attack is still possible. That's why it's so important to find effective way to detect and prevent it.
There have been a few studies looking at FR and dataset distillation separately. For example, both PAD-AF and PAD-DM use dataset distillation to cut down communication costs and improve model performance. On the other hand, HFLDD focuses on solving non-IID data issues with dataset distillation. But none of these studies really focus on security risk like membership inference attacks, especially when FL and dataset distillation are combined. That's where we come in. Several studies have already looked at using dataset distillation in federated learning to make it more efficient. For example, PAD-AF and PAD-DM help cut communication costs and improve how the model works, while HFLDD deals with the non-IID data problem. But the thing is, none of these studies really focus on security risks like membership inference attacks. Even though dataset distillation is being used in FL, the security side of things hasn't really been addressed, and that's where we come in. So here is what we are gonna do right now. No one has really studied membership inference attacks in combination of FL and dataset distillation. Most research focuses more on making things faster and more efficient, but not on the security side of things. That's where we want to contribute. We aim to be first to not only find these attacks, but also figure out how to defend against them in this specific setup. Through our research, we expect to achieve three main things. First, we want to identify the security risks related to membership inference attacks in FL with dataset distillation. Second, we are looking to make data sharing safer by developing stronger defense mechanisms. And finally, we are trying to strike a good balance between privacy and model performance. There are two main challenges we expect to face. First, incomplete security. While we are focusing on membership inference attack, we also need to consider other risks like model poisoning and data reconstruction attacks. Second, model performance degradation. Dataset distillation compress data and add noise, which could reduce the model's performance, especially with already distilled data. We will need to find right balance between performance, and security. In conclusion, our research aims to address a critical gap in federated learning with dataset distillation by focusing on security risk, particularly membership inference attack. We think this work will help make federated learning system more secure and efficient. Thank you for listening.